Hey guys, first thing you need is your yellow notes packet for Unit 8. So if you're my period 3-4, you need to go to day 13, and we're going to do both days. They're only 1 page each. And if you're my period 5 or 7, also Unit 8 notes, but you're going to day 7. We are going to skip day 6 for now, and I'll do that when I come back. So get your notes out. If you need to pause the video, pause the video. Okay, so now we should have notes out, and I'm going to have you guys at the very top. I want you to label these up here as A, B, C. And then I want you to also add, for the graphing method, or if one equation has a fraction. So if you need to pause this, go ahead and pause it, fill this part in. It is important that you have labeled A, B, C, because we will reference it quite a bit. Okay. Then this whole lesson is about choosing your best method. So you know 3 methods. You know the graphing method, the substitution method, and the elimination method. And up here, it just gives you like ways to figure out maybe how you should use these different methods. So if I give you a set of 3 different problems, all linear systems, I want to know which method you would use to solve it, why did you choose that method, and then I want you to solve it. So first, I'm going to look for the graphing method. It says I need to have both equations in SIF, or they can easily be put into SIF, or one would have a fraction, maybe both. So I look to see, I don't see any fractions. I do see that A has this in slope-intercept form, but not this one. It would look like it would take a couple steps to get there. Nope. But then down here, this is in slope-intercept form. This would be easy to get into slope-intercept form. All I would have to do is subtract x. So out of my A and my C, C is the best one to do graphing method with. So since we labeled that A, I'm going to label this A. Now, you're really supposed to write graphing method here and then explain why. And if we explained why, we would say these equations can easily be put into slope-intercept form. Because it's a video, in the sake of time, I'm just going to put A, and we would know that we referenced this information up here. Okay, I'll go back and solve it in a minute, but let's go ahead and move on to which one is the best method for substitution, to solve using substitution. So I look at these two, and I know that I would have 3 steps for substitution. And my first step is which one has x or y by itself. So if I look here, I've got a y by itself. Here, I have nothing by itself. So I believe that A is my best bet for substitution method. So I'm going to say that this is B, substitution method. It says here either x or y is by itself or can easily be arranged to be by itself. Okay, and then C by default has to be elimination method. But why? Okay, I can't cancel anything out the way it is, but I'm pretty sure I can multiply this by a 2 and cancel out my y's eventually. Okay, so since I know what method I'm using for each one, now it's our job to go through and solve them that way. And you already know how to solve them with all the different methods. So for substitution method, we have our 3 steps. Step 1, use the equation that has x or y by itself. Step 2, we use the other equation. We use the expression from step 1, and we plug in to step 2. Because we have a coefficient of 2, we need to put parentheses around our expression. And then I'm going to go ahead and just solve it and not say all the steps. And if you need to rewatch, you are more than welcome to rewatch this part. Okay, and now that I know that x is 3, Step 3 says go back to step 1 and plug in 3 for x in this equation to find y. So I have a negative 6 plus 6, which is 0. So I know that y is 0. Okay. In part B, which is the newest method you've learned, the whole goal is to be able to eliminate one of your variables to solve for the other variable. So I know the opposite of negative 2 is 2. And 1 times 2 makes 2. So let's go ahead and distribute the 2 to all of my terms here. So I've got 2x plus 2y equals 14. And then we will bring down the other equation. We can eliminate our y's, and we would have 5x equals 25. So x, if I divide by 5, is 5. Okay, then you have to pick what equation you want to plug this 5 back into, and it has to be the original equation. It cannot be the new equation that you made. So I go back to the originals. I'm picking the first one because it has less variable, or has less numbers and more positive numbers as well. So this is the first equation. I plug my 5 in for x and I solve. So subtract 5. And we get 2. Okay, and then the last one, for that first equation, we'd have to put it in slope-intercept form. So if I move my x over, it becomes a negative 1x. And we put that over 1, which is positive. So over on the graph, I need to go ahead and start at the positive 3 on the y-axis. And it says that I'm going down 1, but right 1, since the 1 on the bottom is positive. This does yield many points. Okay, and then going the opposite way, up 1, right 1. Sorry, up 1, left 1. I would use a ruler, but I only have one hand to do this with since I'm taping the other part. Okay, and then the second equation, start at negative 2. And then we're going to go up 4 over 1. Okay, so I can tell right now that that's my intersection point. Which would be 1, 2. Okay, so that's page 1. Okay, on the second page, we have the same thing. We need to go ahead and label A, B, C. And again, I want you to make sure you understand that if you see a fraction in one of the choices, then it has to be the graphing method. We are not going to solve elimination or substitution method with fractions. And that seems a little too much. So go ahead, label A, B, C, and then make sure you just write a note that you have to have a fraction there. All right, down here, again, I'm going to look at all 3 of them, and I'm going to figure out what is the best method I should use for each one. So graphing method I'm going to start with, I'm going to look, is y by itself? No. Yes, and it has a fraction. So by default, I can stop here. It has a fraction. I can put this into slope-intercept form easily. So this has to be the graphing method, A. And I'm going to go ahead and put this one into slope-intercept form. So I'm just going to move that 3x over, making it negative. Okay, so that should be pretty simple to graph and get my point. And then I'm now looking for substitution method. So this is where I want x or y by itself for that first step. So I look, no x or y by itself, so that can't be it. Here I've got y by itself, so yeah, this is definitely substitution method, where step 1 would be that y equals negative 2x plus 6. Okay, step 2 is using the other equation. And then step 3 would be using the first equation. Okay, and then again, by default, we know that A has to be the elimination method, but we need to decide why that's true. It says that X or Y can easily be canceled. Well, I don't have opposites here, and I don't have opposites here. So, it says you can multiply one equation to easily cancel out a variable. Okay, so I look here, I've got a -2, I need a +2. So I can multiply this 1 by a +2 and cancel out my variable. So I'm going to go ahead and do that. I'm going to go ahead and multiply. Then rewrite my second equation. And I'm going to work it out so I can cancel my y's. This gives me 8x. And 10 minus 2 is 8. If I divide by 8, x is 1. And then I got to plug it back in. I'm going to choose the first one because the first one has positive numbers and less numbers. So I've got 3x plus y equals 5. We know that 1 should go into x. So I need to subtract 3. 5 minus 3 would give me 2. Okay, so I've got 1, 2 is my answer there. Okay, for the graphing one, I'm going to graph this equation first. So starting at 1, I'm going to go up 1 over 3, and then down 1 left 3. Okay, second one, so start at 11. Obviously we don't have an 11, but that's pretty easy to make. So I'm just going to go right up there at 11 and then go down 3, right 1. So I'm going to cross there. And so my answer is 3, 2. Okay, and then lastly, I already have this set up. So I'm just going to plug in my expression for y. I need parentheses. Please note that's a -1x. So we would get -6x plus 18 minus 1x equals -3. This will give you -7x. Subtract 18. And then if you divide by -7, you get 3. Okay, so I know that my x is 3. And if I plug that back in up here, we get 0. Okay. Next,